What's up, Precalc students? I'm coming from over here today. We learned about expanding binomials, how it's not so easy as like cubing 2x and saying this is 8x cubed and cubing 3 and saying that's 27. You know better than that. What instead we do is either brute force it or use the binomial theorem in Pascal's triangle. Okay, I'm going to do both. Now, what we found in class is when we distribute A plus B, we did that using brute force. We notice these numbers show up, and these are from Pascal's triangle. They ended up being coefficients of things. I'm going to show you two ways to do the problems. One, brute force. Here's brute force. If you got 2x plus 3 cubed, you'll have it 3 times. If you square it, I'm not going to show you all these steps. You would be able to do this either using the box or understanding distribution. I'm going to do 2 things at a time. I'm going to get 4x squared. I'll have 6x's and 6x, which is 12x's. I got 3 and a 3, which is a 9. Now, multiplying this by 2x plus 3, even I need to kind of write it down. Now, again, if you want to use the box, use the box. It helps prevent mistakes. 8x cubed, I'll have 12x squareds and 24x squareds, which is 36x squareds. I'll have how many x's? 36x's and 18x's. 18 plus 36. 54x's. What's my numbers? 9 and 3, 27. Okay, that is brute forcing it. Now, here's the other way we could do it. Binomial theorem. You will have a cube. This is the 0th power. This is what happens if you're first power. This is the 2nd power. This is the 3rd power. So these are going to be the coefficients of my 3rd power. Here's what we're going to have. We'll have a 1, our first term cubed, plus a 3, our first term squared, our second term to the first, plus a 3, our first term to the first power, our second term squared, plus a 1, so there's 1, 3, 3, 1, our second term cubed. So I got 1 times 2x cubed, 3, 2x squared, another 3. 3, 2x, a 3 squared, a 1, a 3 cubed. Ready? 2x times 2x times 2x is 8x cubed. Check. 2x times 2x is 4x squared. 4 times 3 times 3. That's 4 times 9, which is 36x squareds. Check. Three squared is 9 times 2, which is 18 times 3. Or 27 times 2 is 54. Boom, 54 x's. Check. 3 times 3 times 3 is 27. Check. Which way is quicker? I don't know. Brute force is probably all you need to do, but the binomial theorem is always there to help you. So let's brute force this guy. X plus 1, x plus 1, x plus 1, x plus 1. I'm going to just multiply these two together and these two together. I get x squared plus 2x's plus 1. I'll multiply these two together. Same thing. Now when I multiply these two together, again, box it. Do the distribution. Well, yeah, I'm not going to show you the box. Like, you can do the box. Just do it. If you know how to do the box, do the box. If you can't do what I'm doing, don't do what I'm doing. I'm just showing you the answers. I get an x to the 4th. How many x cubes do I have? I have 2x cubes. I have 4x cubes. How many x squareds do I have? I have 1x squared. I have 4x squareds. I have 2x squareds. So, and another x squared. So 1x squared, 2x squared, 3, 4, 5, 6x squared. How many x's do I have? I have 2x's, 2x's, 4x's. How many numbers do I have? 1 and 1. Use the box to get this. Now, what do we notice? Like 1, 4, 6, 4, 1. Fourth power. Let me show you how it's done. Using the binomial theorem, you have 1 first term to the fourth plus 4 first term cubed second term to the first plus 6 first term squared second term squared plus 4 first term to the first second term cubed plus 1 first term to the 0 second term to the fourth. So we'll have x to the fourth, x cubed, 1, x squared, 1, x to the first, 1, 1 to the fourth. This is how we get the same thing using the binomial theorem. Cool. All right, I'm going to use the binomial theorem. Or you can brute force it. It's the x cubed, 1, 3, 3, 1. I'll have my first term cubed. I'll have my first term squared, second term to the first. I'll have my first term to the first, second term squared. I'll have my second term cubed. 4x, negative 1. 4x, negative 1, negative 1. 4 times 4 times 4 is 64 x cubes. 16 times 3, 48 times negative 1, negative 48 x squareds. I got 12 x's, and I got a negative 1. Bam! Binomial theorem, Pascal's triangle, or 4x minus 1 times 4x minus 1 times 4x minus 1. I'll get 16x squared minus 4x is minus 8x plus 1 times 4x minus 1. Use the box. 16 times 4, 64 x cubes. How many x squareds? I have negative 16x squareds and negative 32x squareds. Negative 16 and negative 32 is negative 48. Check. How many x's do I have? I have positive 8x's and positive 4x's, 12x's. Check. How many numbers do I have? 1 times negative 1. Check. Okay, the reason why it's important to know how to distribute things is sometimes we need to add or subtract polynomials just to understand what the polynomials are doing. So here's an example. X minus 3 squared is x squared minus 6x plus 9. If you need to use the box, please use the box. I'm going to be showing you the box in class, so make sure you don't forget the box. 2 minus x cubed. You can use the binomial theorem. Let's just brute force this just because I don't have space. I get 4 minus 2x minus 2x minus 4x plus x squared. And that needs to be multiplied by another 2 minus x. Okay, so I have x squared minus 6x plus 9 here. I'm going to have a negative x cubed. That's my x cubes. I'll have positive 2x squared and positive 4x squared, which is positive 6x squareds. How many x's do I have? I have positive 4x's. I have negative 8x's. Minus 4x's. How many numbers do I have? 4 and 2. I have 8. I'm going to double check that using the binomial theorem in just a second. If we add all this stuff together, I got negative x cubes. I got 7x squareds. I got negative 10x's. And I got 17. Bam. I got to double check. This is what the binomial theorem is kind of there for. You double check your 2 minus x cubed. Cubed coefficients are 1, 3, 3, and 1. I'll have my first term cubed, my first term squared, my second term to the first, my first term to the first, my second term squared, my second term cubed. First term's 2. 2, negative x. 2, negative x, negative x. Okay. 8, negative 12 x's. 2 times 2 is 4. 3 times negative x to the first. 6, positive x squared. Negative x cubed. 8, negative 12x. Oh, shoot. Negative 8x's, negative 4x's. Damn. Yo, this is why we do this. Oh, shit. We're supposed to use the binomial theorem down here. All right, so let's brute force it. Nine x squared, negative 6x, negative 6x, negative 12x's, positive 4 times another 3x minus 2. Yo, break out the box. Let's do it. If I were to redo this video. (27x cubes, negative 36x squareds, 12x's, negative 18x squareds, 24x's, negative 8. Add them together. 27x cubes, 54x squareds, 36x's, negative 8. Nine x squared, I'll have 12x's and another 12x's, which is 24x's, 16. I've done x minus 1 cubed before. X cubed minus 3x squared plus 3x minus 1. It's literally the binomial theorem. You could do that yourself. X cubed, 6x squareds, 27x's, 15. This is the original photo math. X cubed, 6x squared, 27x is 15. Okay. All right. Let's use the binomial theorem. Here we go. Just the binomial theorem. Here's our cubed, third power. Here's our fourth power. No, this is our squared power. My bad. Remember, like a plus b to the 0 was just 1. So this is the 0th power. If this is the first power, a plus b to the first is 1 and 1. This is the cubed. Here's the fourth. And here is the fifth. 1, 5, 10, 10, 5, 1. Okay, ready? 1, 5, 10, 10, 5, 1. Descending powers, ascending powers. First term to the fifth, second term to the 0. First term to the fourth, second term to the first. First term cubed, second term squared. First term squared, second term cubed. First term to the first, second term to the fourth. First term to the 0, second term to the fifth. Plug in. x, x2, 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 x. X to the fifth plus 5x to the fourth times 2, 10x to the fourth plus 4 times 10, 40x cubed plus 8 times 10, 80x squared plus 2, 4, 6, 2, 4, 8, 16 times 5. I know this. 80. 80 x's. Yep. Plus, sorry, this is 2 to the fifth. My bad. Second term to the fifth. First, the second term is to the 0th power. Here, the first term is to the 0th power, the second term is to the fifth. 2, 4, 8, 16, 32. Bam! If you brute forced it, you would get it. Just take you a while. Ten x to the fourths, 40x cubes, 80x squareds, 80x's, 32. Got it? Okay, the next one is a 4th power. 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. Descending powers for the first term, ascending powers for the second term. Or just like be consistent. It actually doesn't matter. So, first term to the fourth. First term cubed, second term to the first. First term squared, second term squared. First term to the first, second term cubed, second term cubed. What are the terms? 3x and 2. So 3x and it's negative 2. Be careful with that. 3x and negative 2. 3x and negative 2. Negative 2. 3, 9, 27, 81. X to the fourths. 3, 9, 27 times negative 2 times 4. Does that work? 216. Times 4 times 2. 216. Okay. It's a negative 216 because I got a negative 1. Negative 216 x cubes. 9 times 4 times 6. So that's 36 times 6. 216 again. Positive because we got this negative 2 being squared. 4 times 3 times negative 8. Negative 96. X, negative 8. Okay? That's the binomial theorem. That's how we can do 3x minus 2 to the fourth using brute force. Without using brute force. See if I got it right. 81x to the fourths minus 216 x cubes plus 216 x squareds minus 96 x's plus 2, 4. Oh, shit. I forgot this is a 4. 2, 4, 8, 16. Whoops. And it's a positive 16. Signs alternate. All right. Now I could give you something that's like completely in factored form. You could think about what you'd get if you distributed everything. You don't have to distribute everything because we know it's all about the highest degree term. That gives you the degree of the polynomial. That's going to be the biggest infinity. And it's all about the leading coefficient of that. So what I have to actually care about is this 2x, this x being squared, and this 3x being squared. So this is x squared, this is 9x squared, this is 2x, this is x. I have 1, 2, 3, 4, 5, 6 x's and a positive 18 in front of it. So the degree of the polynomial is 16, the leading coefficient is 18. It's like 1, 2, 3, 4, 5, 6 x's, 2 times 1 squared times 3 squared 18. The zeros are at 0 with a multiplicity of 1, at 3 with a multiplicity of 1, at -4 with a multiplicity of 2, and at 5/3 with the multiplicity of 2. You take this equation, add 5 divided by 3, set equal to 0. If it is positive x to the even, we're thinking about positive y equals x squared. We're a touchdown to the left, I'm going up. To the right, I'm going up. What would the graph look like? Well, like, again, you don't have to use the end behavior. You could just use a sign chart. But like, this end behavior is telling you you have positives. You are going to bounce at -4. You're going to bounce at 5/3. So sign change, no sign change, sign change, no sign change. That makes sense because you end up positives. So here we go. We bounce, we pass through, we bounce, we pass through. I don't know if I have enough time. 1, 2, 3, 4, 5. This is an x to the 5th polynomial. -2 times 2 squared times 1. That's 4 times -2. That's -8. That's the leading coefficient. My zeros are x equals 0. Multiplicity is 3. We're going to have a bend. X equals -1/2. That's a multiplicity of 2. We're going to have a bounce. And x equals 3. Multiplicity of 1. If it's a negative x to the 5th, we're thinking about negative x, x cubed, positive x cubed, negative x cubed. So negative x cubed has end behavior like this. If I go to the left, I'm going up. If I go to the right, I'm going down. If you want to, you can use that end behavior to help you. I got -1/2, 0. I'm going to bend through 0. I'm going to bounce off of -1/2. And then 3, I'm going to change signs here. I know I have negatives here and positives here. By end behavior, I can use a sign chart, plug in something like 4. I got a negative, a positive, a positive. That's a negative. Change signs, change signs. Ooh. What did I mess up on? Three, four, five. Oh, shit. Look at that. Like, I'm making mistakes because I'm rushing, but I'm also figuring out the mistakes made because something wasn't right. I thought it was an x to the 5th. I thought I had the end behavior. I did a test point and I did a sign chart, and then something didn't work out. It's like, oh, I'm supposed to bounce and stay negative. Well, I do, because this is a negative x to the 6, which means we are angry gorilla, negative x squared. So it should make sense that this is also a negative, and it does with our bounces and our bends. Sign chart check, change signs, bounce. So negatives, bounce, bend, pass through. You get what I mean. I kind of lost it there with my hand. But bend, pass through. Damn, got a factor. This is a cubic with a leading coefficient -3 because this is our highest degree term. End behavior of a negative cubic is just like we talked about, negative x squared. So to the left, I'm going up. To the right, I'm going down. I have to factor. (25) plus 10x plus x squared. That's x plus 5 squared. I can tell the two numbers that add to get 10 and multiply to get 25. So this is -3x times x plus 5 squared. So that means x equals 0 has a multiplicity of 1. X equals -5 has a multiplicity of 2. We know that our multiplicities of 2 are bounces. So -5, we're going to have a bounce. X equals 0 is going to be just a pass through, a sign change. We're not going to change signs on bounces. That even powered prevents that. Squaring things will always have the same sign depending on the leading coefficient. You could test a sign, or you could use your end behavior to know this is negative. If I plugged in 3, negative, positive, okay, that's a negative. Change signs. End behavior leads you to that. Bouncing off works that way. Bounce off, pass through, we win. All right, last one. I got 2 minutes. You guys are about to rush in here. 3x, x squared minus, oh, look at that tricky one. Never mind. It's a negative x to the fourth. Rewrite this. Okay, factor this. X equals 0, multiplicity is 2. X equals 5, multiplicity is 1. X equals -4, multiplicity is 1. It's a negative x to the fourth. That means I'm down and down, like negative x squared, down and down. If I wanted to sketch the graph, I got -4, 0, and 5. -4, sign change. 0 is a bounce. 5 is a sign change. You could test your sign. Plug in something like 6, negative, positive, positive. I see a negative. That's confirmed that I'm having negatives using my end behavior. Change signs, bounce, change signs. That's confirmed with this end behavior. Pass through, bounce off of, pass through. Done. Later.